नमस्कार विद्यार्थी मित्रो, मी सचिन पाटील कॉम्पिटिटिव्ह पोटेन्शियल टू अचीव्ह सक्सेस या यूट्यूब चॅनलमध्ये आपल्या सर्वांचं स्वागत करतो. MPSC आणि UPSC मध्ये एक महत्त्वाचा ऑप्शनल सब्जेक्ट येतो तो म्हणजे मॅथमॅटिक्स, ज्याच्यामध्ये पेपर नंबर 1 250 मार्क, पेपर नंबर 2 250 मार्क कॅरी करतात. या सब्जेक्टची खासियत ही आहे की याच्यामध्ये ज्यावेळी तुम्ही एखादा एक्झाम्पल किंवा एखादी गोष्ट सोडवता, त्याच्यामध्ये तुम्हाला पैकीच्या पैकी मार्क द्यावेच लागतात जर तुम्ही ते परफेक्ट सोडवलेलं असेल तर. इतर सब्जेक्टचे आपण जर विचार केला तर त्याच्यामध्ये तुमचा ॲन्सर क्रिटिसाइज करता येऊ शकतं, त्यामुळे तुम्हाला पैकीच्या पैकी मार्क देता येऊ शकत नाहीत. या सब्जेक्टमध्ये आपल्याला पेपर नंबर 1 मध्ये ऑर्डिनरी डिफरन्शियल इक्वेशन एक खूप महत्त्वाचा टॉपिक बघायला मिळतो. त्याच्यामध्ये ऑर्डिनरी सेकंड अँड हायर ऑर्डर डिफरन्शियल इक्वेशन, याच्यामध्ये आपण nth ऑर्डर ऑर्डिनरी डिफरन्शियल इक्वेशन विथ कॉन्स्टंट कोएफिशियंट याचा विचार करत होतो. मागच्या लेक्चरमध्ये आपण कॉम्प्लिमेंटरी फंक्शन कशा पद्धतीनं काढायचं ते बघितलं. जर समजा आपण एखादं इक्वेशन घेतलं, equation is in the form of constant coefficient, it is nothing but a0 dn y divided by dx raised to n plus a1 dn minus 1 y dx raised to n minus 1 plus a2 dn minus 2 y divided by dx raised to n minus 2 plus and so on up to plus a n minus 1 into dy by dx plus an is equal to 0. An is equal to q of x. When we put the q of x is equal to 0, q of x is equal to 0 and d is nothing but a d dx, d square is nothing but d square is equal to d2 divided by dx square and so on up to dn is equal to dn divided by dx raised to n is there. You will get the equation of a0 d raised to n plus a1 d raised to n minus 1 plus a2 d raised to n minus 2 plus and so on up to plus an minus 1 into d plus an into y is equal to 0, and this is your homogeneous equation which is found from the equation 1 is there. So we just replace d by m, and you will get the auxiliary equation that is a0 m raised to n plus a1 m raised to n minus 1 plus and so on up to plus an is equal to 0, and solving this you will get the m1 m2 m3 and so on up to mn are the roots. Then case number 1 is what? All roots are real and distinct. Then you will get the cf is equal to what? c1 e raised to m1x plus c2 e raised to m2x plus and so on up to plus cn x e raised to mnx is there. Then we are going with the r roots are same. Then cf is equal to c1 plus c2x plus c3x square plus and so on up to plus cr x raised to n r minus 1 plus e raised to mx plus c r plus 1 e raised to mr plus 1 into x plus and so on up to plus cn e raised to mn x is there. Okay, and this is your solution. And then if any two roots are complex there, then we find out the case number 2 is there, and any two roots, that means m1 is equal to alpha plus beta I and m2 is equal to alpha minus beta I is there. Then cf is equal to cf is equal to what you can say, e raised to alpha x inside the bracket c1 cos beta x plus c2 sin beta x plus c3 e raised to m3x plus and so on up to Cn e raised to mn x is there. And if case number 3 is there, m1 is equal to m2 is equal to alpha plus beta I, and m3 is equal to m4 is equal to alpha minus beta I, then cf is equal to e raised to alpha x inside the bracket c1 plus c2x into cos beta x plus c3 plus c4 x into sine beta x plus c5 e raised to m5x plus and so on up to plus cn e raised to mn x. Those are the complementary functions related with that one. Then we are going with a particular integral, and particular integral, it is nothing but for this purpose, first of all, this equation is a this equation is converted into let fd of y into q of x. F of d is nothing but what? F of d is nothing but this equation, and this equation gives f of d, and according to that you will get the particular integral is equal to 1 divided by fd into uh, q of x. 1 divided by fd into q of x is there. This is a general form. When e raised to when your q of x is equal to e raised to ax, sometime it is a sin ax, cos ax, x raised to n, into g of x, where g of x is also once again e raised to ax, sin ax, cos ax. So cos ax raised to n is there. Then e raised to ax into g of x. G of x is equal to once again sin ax, cos ax, x raised to n is there. Then you will get the different particular integration. In first type 1, we are just concentrated on q of x is equal to e raised to ax is there. E raised to ax is there. Okay, in type 1, we are just going with q of x is equal to e raised to ax. Then pi is equal to 1 divided by f of d into e raised to ax. But replace d by small a, and you will get the first case f of a is not equal to 0. D is replaced by a, then f of a is not equal to 0, then pi is equal to 1 divided by f of a into e raised to ax is there. And if f of a is equal to 0, then f of d is equal to d minus a raised to r into what you can get into g of d. G of d is there. F of d is equal to d minus a raised to r into g of d. At that time you will get the pi is equal to 1 divided by d minus a raised to r into g of d into e raised to ax is there. And replace d by a, you will get the particular integration is 1 divided by d minus a raised to r into g of a into e raised to ax, and 1 divided by d minus a raised to r having the value is x raised to r divided by r factorial e raised to ax into g of a is here. And this is your final solution or particular integration related with the type 1, where q of x is equal to e raised to ax is there. According to that, first of all, we have to find out the complementary function and then particular integration. Then we get the general solution of the nth order ordinary differential equation with a constant coefficient is there. This is the method which is for finding the solution of the nth order ordinary differential equation with a constant coefficient. And it is having a first type where type q of x is equal to e raised to ax. We just concentrated on that first type, and we are going with the example related with the type 1, type 2, and so on thoroughly. First of all, we know this theory related with the finding the general solution of a nth order ordinary differential equation with a constant coefficient. जर हे तुम्हाला समजलं असेल तर लाईक करा, शेअर करा आणि सबस्क्राईब करायला विसरू नका. थँक्यू.